Hey everyone, today I am showing you how to build an AI-powered chatbot that lets you chat with any PDF using NTN, Gemini, and Pinecone. By the end of this video, you'll have your own workflow that takes a PDF, stores its content as embeddings, and lets you ask natural language questions just like ChatGPT, but for your documents. This is the workflow in NTN, and what this workflow does is that you upload a PDF and it extracts the content, splits it into chunks, embeds those chunks using Google Gemini, and stores them in Pinecone for future retrieval. The first node that we have is a trigger node, when clicking Execute Workflow. This basically starts the workflow, and it's useful for testing or uploading a static document. Second is the download file using Google Drive module. Make sure to connect your credential correctly with your account. Resource will be file. Basically, this is a node in NTN that downloads the PDF file from your Google Drive. That's why we are connecting it with our Google Drive account, so make sure to have your credentials set. When your Google Drive account is linked correctly, you will be able to see the content of your Google Drive. So I've uploaded the file that I want the AI agent to analyze, so first upload it into Google Drive and then you'll be able to see it over here. Select that. This basically fetches the actual PDF file that the user wants to ask questions about. One more important thing is that we know that a PDF is not just words, it's a structured file. When you download a file in NTN, like a PDF, it's not just plain text like a paragraph. It contains images, formatting, fonts, and other encoded data. All of this is non-human readable, so it gets stored as a binary object. Binary data stores the actual file content, so it's basically encoded. That is needed for file-related operations in NTN. After that, we have the Pinecone vector store. So what does this step do? Basically, this step saves the smart understanding of your document in embeddings into a tool called Pinecone, so it can be searched later, kind of like saving a note in a smart notebook that can find similar notes when you ask a question. If you do not know what Pinecone is, it is a vector database. Simply go into pinecone.io and make your account. The vector database doesn't store plain text, it stores vectors, which are just smart number representations of your document's meaning. Log in with your account or sign up with a Google account if you haven't. After logging in, go to Create Index. Give it a name. I'll just say Project. Then you have to select your configuration. I'm using Gemini, but if you're using OpenAI, then you can select Text Embedding 3. But as I'm using Gemini, I'll do BATO configuration. The metric will be cosine, which is commonly used in vector search when working with text embeddings. It basically measures the semantic similarity between text, helping find which part of the PDF is most like your question. For dimensions, we need to use dimensions that match the Gemini's embedding output size, which is how many numbers Gemini uses to represent each sentence. For this, we need 3072. After that, just click on Create Index. You can see your index has been created, and its name is Project. If you're confused about what embeddings are the AI-generated numbers that represent chunks of your document. For example, if you give a chunk of text to Google Gemini, it will give you back a list of numbers. This embedding tells the AI what the text means. You don't read embeddings, the AI uses them to compare meanings. After you're done, your index is made, then go to your API keys and copy and paste the API key to your configuration. Create a new credential and then connect, using that API key to connect with your Pinecone account. Then your Pinecone account will be linked. The operations mode will be Insert Document because we're going to be inserting the document. After your account is configured, select the index that you just made, which is Project in my case. This is basically the name that you would give to your project, so we are going to be analyzing the financial data of IKEA, which is a report that I'll be uploading to this workflow later on. That's why I'm giving it the name IKEA. You can name it whatever your document is. After that, we have the default data loader. The default data loader is basically like a text extractor. You give it a PDF file, and it gives you text from that file. When you upload a file like a PDF, it's usually in binary format, which is just computer data that humans can't read directly. Before you can analyze it with AI or embeddings, you need to convert it into plain, readable text. That's why we have the default data loader. The type of data you will select is binary, load all input data, and then text splitting custom. After this, we have the recursive character text splitter node. This is basically a smart paper cutter for text. It cuts long text into smaller parts called chunks while making sure the meaning stays clear. These chunks are small enough for AI models like Gemini to understand and process properly. For example, imagine that you give someone a huge book and ask them a question about it. They'll struggle with it. But if you give small meaningful pages, it's easier to read, remember, and answer questions from. AI models like Gemini work the same way. They can only read a limited number of characters, tokens, at once. In simple terms, this node breaks long text into smaller parts. The chunk size can be 1000, and this is your Google Gemini embedding, so I'm using Gemini. You need to connect with your Google Gemini account. You can go to your Gemini account and get your API key from there and connect it to this. For the model, you'll use Gemini embedding 001. Now that this workflow is explained, we'll execute it and see what happens. After this is done, we'll go to our second workflow, save this workflow, and go to the second one, which is where we will ask questions about the PDF. The second workflow starts with when chat messages are received. This node acts as the entry point of your workflow. Whenever a user sends a new chat message, this node triggers the whole process. It receives the incoming message and passes it on to the next node, which is our AI agent. This AI agent is the main brain of the workflow. What it does is that this AI agent processes the incoming message and coordinates which models are used to generate an answer, manages memory, and decides if any tools are needed for advanced actions, like searching or storing data. Over here, the connected chat trigger node will be selected. Your prompt user message is basically when you execute the previous node, then you'll just put the chat input over here. For example, let's just say hello for now. It says, "Hello, I'm an AI system designed to help you with the IKEA Group Financial Summary FY23. I can answer questions about the document, such as Rimini profit system existence, sustainability goals, store performance, and more. How can I assist you today?" Your prompt is the user message. It's a chat input. Just drag this over here and paste it over here. This is how you will get it. This is the system message that you give for the AI agent, explaining what it has to do. First, you will write its role. You are an AI assistant specialized in answering user queries based on the IKEA Group Financial Summary FY23 provided as a PDF. You extract, understand, and explain relevant financial and operational information from the document. Your task is to understand the uploaded IKEA FY23 financial summary using vector embeddings via Pinecone. Accurately retrieve and summarize information from the PDF based on user queries. Answer follow-up questions using the context of previous queries and extracted data. Specifically, only use information from the uploaded PDF unless the user explicitly asks for external general knowledge. This is because you can also add other notes like Wikipedia and NTN. Sometimes the model can also use other sources. Provide concise, well-structured answers. If the answer is not found, then just respond with, "This information is found in the uploaded document." Use a tone that is professional, clear, and aligned with IKEA's brand context. The user may ask about revenue, profits, or cost breakdowns, sustainability, climate goals, global store performance, and expansion. Examples include user questions like, "What was IKEA's total revenue in FY23?" and "What are IKEA's estimated focus areas?" At the end, some notes. Stick strictly to facts from the PDF. Do not generate answers based on assumptions or outside knowledge unless explicitly asked. These were some notes. This is the system message for the AI agent. After that, we have the Google Gemini chat model. This is the large language model responsible for generating chat responses. Again, you need to connect it with your account. When the agent needs to generate a natural-sounding chat reply, it sends the user's message here, and the Gemini model responds with relevant conversational text. This is the output showing. Simple memory keeps track of what's been said before. This node stores previous chat history or data needed for context. For example, if the conversation requires remembering something from earlier, this node provides that memory. That's why this is important, because sometimes the user might have follow-up questions. We need to use the simple memory node for that specific reason. The session key from the previous node is over here. The context window length is 5. Next is the Pinecone vector store, again connected to your Pinecone account. The description is to call this tool to get information about IKEA's earnings to answer the user's questions. From the list, again, you need to select your index. The Pinecone vector store is a place to search and store vectorized representations of data, so the AI can use this node to find information quickly. For example, if the chat needs to refer to a document or previously shown answers, it searches here using semantic search, like finding similar meanings, not just keywords. This is the index, how we create the text. Pinecone namespace IKEA. The embeddings Google Gemini convert text into vectors called embeddings for searching in Pinecone. If the system needs to compare the meaning of user queries against the database, for example, finding the most relevant answer in a knowledge base, this node transforms the chat text into vectors, which are then stored or searched inside Pinecone. We have executed the workflow. We can open the chat and ask questions to the chatbot. Let's ask some questions. How much did retail sales grow by FY22? Just for a short preview, this is what the document looks like. I'm asking this question right here. In the document, it says compared to FY22, retail sales grew by 6.6%. We asked the same question over here, and it says IKEA's retail sales grew by approximately 6.4% in FY22. Let's see what else we can ask. We can ask about tangible fixed assets. According to the PDF, tangible fixed assets are defined as things like real estate and equipment that you can physically touch and feel for IKEA Group. These mainly include factories and distribution centers. The document also mentions that the entire IKEA Group owns several offices, distribution centers, the IKEA docks, the IKEA store, the IKEA hotel, and the IKEA museum. We can ask about IKEA Holding B. IKEA Holding is a holding company of the IKEA Group. It is based in the Netherlands, where the group management of IKEA Group is located. IKEA Group has 3 core businesses. It also gives the page that it is on, so page 6, as you can see. Now, remember we talked about the memory part. Let's ask the chat to give a summary of this shot. If the memory was not there, then it wouldn't understand what this text means, right? But because it stores the previous conversation, it gives the chat cover the following topics: FY202 retail sales growth, tangible fixed assets, and IKEA Holding, and that's a wrap up on our AI-powered PDF analyzer using NTN, Gemini, and Pinecone. I hope this gave you a clear, hands-on understanding of how document processing and vector search actually works. Thank you so much for watching. If you found this helpful, feel free to like, share, or drop your thoughts in the comments. See you in the next one.